Hey there, Unmaskers. Welcome to my channel, Unmask It Now. Thanks for tuning in today. In today's episode, we'll explore how to configure SSM agent for EC2 instances when launched in public and private subnets. If you're new to SSM agent, I highly recommend that you watch my other video titled All You Need to Know About AWS Systems Manager first. Hit the link at the top right corner of the screen to watch it. If you're ready, let's now proceed to today's topic. In my earlier video, I covered different networks where machines reside and how you can configure SSM agent in each of their networks very briefly. You must be familiar with this diagram that we discussed in the earlier video. You can see the AWS region with a VPC and a public and a private subnet, and the instances that are launched in the public and private subnet respectively. The instance in the public subnet reaches the SSM endpoints via the internet gateway, and the instance in the private subnet reaches the SSM endpoints via the NAT gateway. Today, we'll expand on this and actually look into the steps to configure it. We won't be looking into configuring SSM agent for hybrid machines, which are machines outside of AWS in this video. So the focus of today's video is going to be SSM agent configuration for EC2 instances in public and private subnets only. In a nutshell, we'll get started by creating a VPC with a public and private subnet. By definition, a public subnet is one that has a route to Internet Gateway, and instances in the public subnet need to be associated with the public or an elastic IP. A private subnet is one that has outbound Internet connectivity via the NAT gateway or a NAT instance, and instances in the private subnet will only be associated with the private IP. After creating the subnets, we'll launch instances in each of these subnets using the latest Windows AMI. This should have SSM agent installed by default. Once the instance is launched, we'll go over the steps required to configure the agent to report the instance as a managed node. Switching over to the AWS console, let's now simulate an environment or a network where we create a VPC with a public and private subnet. To do so, let me switch to the VPC console. Click on Your VPCs, Create VPC. I'll be using the VPC wizard that actually creates the public and private subnets for me. So I'll click the VPC and More. I'm going to leave the defaults for the VPC name and the CIDRs. Select the number of availability zones as 2. Customize the availability zones where I'll create 2 public subnets and 2 private subnets. In the private subnet, I do want 1 NAT gateway per AZ. We won't be using any VPC endpoints, and I'm going to leave the DNS attributes for the VPC as enabled. Verify that the subnets and route tables are as expected, and then go ahead and click on Create VPC. I'll give it a couple of minutes for the resources to create. Now that it has created all the resources, let's go ahead and view the VPC. I can see that I have my project VPC. It has 2 public subnets and 2 private subnets. Let's take a look at the public subnet route table. We do have a route to the Internet Gateway, and let's take a look at the private subnet route table, which has a route to the NAT gateways. So our setup for the VPC is done. There is one more setting we have to do before we proceed. For the public subnets, I do want to set the auto-assign public IP settings to true. What this basically does is any instance that's launched in these public subnets will automatically get a public IP if the setting is enabled at the subnet level. You can also enable the setting per instance, but for simplicity, I'm going to enable that in the subnet level here. So let's select the public subnet, hit on Actions, and then edit the subnet settings, enable auto-assign public IP address, and then click on Save. I'm going to do the same settings for the other public subnet that we have. Now that we have set the public IP settings on the public subnet, let's go ahead to launch the EC2 instance in the public subnet and then see what steps we need to go through to configure the instance in the public subnet to register as a managed instance for SSM. Let's switch over to the EC2 console. Click on the Launch Instances tab. I'm going to name my instance Windows Server Public. Let's select the Windows AMI. I'm going to stick to the latest Windows AMI. For the key pair, I will use a key pair that I already have. If you do not have a key pair, please proceed to create a new key pair and associate that when launching the instance. Let's edit the network settings to choose the VPC that we just created. I'm going to choose a public subnet. It has auto-selected one of the public subnets, so that's good. And as you can see, since we have enabled the auto-assign public IP from the subnet level, this setting is enabled by default. Let's go ahead and create a security group. I'm going to name it as public security group, just so it's easy for me to identify. And then for the rules, I'm going to just leave it with the default RDP rule, but just change the source to my IP so that I'm able to log into the instance. I'm going to leave the storage as default and then proceed to launch the instance. I'm going to give it a couple of minutes for the instance to enter the running state and the status checks to pass. Once done, we'll proceed to log into the instance. I can see that my instance is in the running state. Let me do a quick refresh, but the status checks are still initializing. Now that the checks have passed, let's proceed to connect to the instance. First, let me get the public IP for the instance. Switch over to my remote desktop application and then paste the public IP. The username for login is going to be administrator, but let's proceed to retrieve the Windows administrator password. So I'm going to click on connect, RDP client, and then upload my private key file, then decrypt the password. Switching back to my application, I'm going to save the settings. Click on continue. We'll be going over the checklist to report a public EC2 Windows instance as a managed node. The first step in the checklist is to verify the sysprep state of the Windows instance. SSM agent detects the status of Windows images before starting the agent and expects the sysprep state to report as image state complete. If the sysprep state is not as expected, the SSM agent will not be running and will be stuck in the starting state. Now that we are logged into the Windows instance, let's move on to check the first item in our checklist, which is the sysprep state. To verify that, let's go to the registry editor. So let me type in regedit. So let's navigate to HKey local machine, software, Microsoft, Windows, current version, setup, state, and verify that the image state is image state complete. If you see that the value of this registry key is anything apart from this, you will notice that the SSM agent will be stuck in the starting state. So make sure that the value matches the image state complete for the image state. Now that we have verified the sysprep state, let's verify the agent state. SSM agent on latest Windows AMI are installed by default and the service is set to automatic start on Windows boot. To do so, let me navigate to the services console and locate the Amazon SSM agent service. Since this is the latest Windows AMI, Amazon SSM agent is available by default and it's installed. All you need to verify is that it is in the running state. As you can see here, the Amazon SSM agent service is in the running state. With the SSM agent running, next we need to verify that the network firewalls between the agent and the public endpoints are not blocking desired traffic. SSM agent initiates outbound communication to the endpoints, so we are only concerned with the outbound rules for the OS firewall, security group, and NACLs. First, let's verify the Windows firewall. By default, the outbound rules for the Windows firewall are allowed by default for the profile that is active. So let's verify that. Navigate to the Windows firewall console by typing in wf.msc. We can see that the public profile is active. So let's navigate to the Windows Defender firewall properties and verify that for the public profile, the outbound connections are allowed outbound by default. So SSM agent is the one that always initiates the outbound connections to the endpoints. So all you need to verify is the outbound rules to make sure that there are no rules that is blocking the connectivity to the endpoints. Now that we have verified the Windows firewall rules, let's take a look at the security group outbound rules as well. Switching over to the AWS console, I'm going to select the instance, switch to security and click on the security groups, and then verify the outbound rules. As you can see, the outbound rule, we have all traffic allowed to any destination. So we are good with the security group rules. Let's now verify that the NACL rules are not blocking. Click on the networking tab. Let's click on the subnet and then switch to network ACL and look at the outbound rules. You can see that we have the default outbound NACL rules, which allows all traffic by default, as the rule number 100 is lower than the infinite rule that we have here. So now that we have verified that the Windows firewall rules, the security group, and the NACL outbound rules all allow traffic, we should be good to verify the connectivity between the SSM agent and the endpoints. With the firewall rules in place, we'll verify if the DNS server configured for the instance is able to resolve SSM public endpoint names to public IPs in the Amazon IP range. To do so, let me launch the PowerShell tab. And then run an NS lookup for the SSM agent endpoint, which is ssm.region AP Southeast 2 in my case, .amazonaws.com. When you resolve the SSM agent endpoint, you need to make sure that it resolves to a public IP. Let's do the same for the EC2 messages endpoint as well. So NS lookup EC2 messages dot AP Southeast 2 .amazonaws.com. You can see that the EC2 messages endpoint also resolves to the public IP. If you have trouble resolving the endpoint names to their public IP addresses, which falls in the Amazon IP addresses range, make sure that you verify the DNS server that is configured on the EC2 instance, as well as the resolution that needs to happen through the DNS server for these endpoints. With the successful name resolution of the endpoints, we can now test the connectivity to those endpoints. Next, we'll verify the connectivity to these endpoints on TCP port 443. Since we've already verified the outbound firewall rules of the Windows firewall, security group, and NACLs, this should be a straightforward connectivity and our check should pass. So let's just verify that. To do so, let me type in test-net connection. -computer name. Let's pick up the first endpoint. -port 443. We can see that the TCP test has succeeded and has resulted in true, which means that the SSM agent has connectivity to the SSM endpoint. Let's perform the same test for the EC2 messages endpoint and verify the connectivity. You can see that the TCP test has also succeeded for the EC2 messages endpoint. So through these tests, we've verified both the name resolution for the endpoints and the connectivity to the endpoints. Now that the connectivity to the endpoints is established, SSM agent needs access to the instance metadata to obtain temporary credentials if any IAM role is attached to the instance. Let's now verify the access to the instance metadata on the instance. On the Windows instance, the instance metadata is reachable on HTTP 169.254.169.254. So let's try to browse to that location and see if we are able to reach the instance metadata. So the connectivity to the instance metadata on the instance looks good since we are able to reach 169.254.169.254. With access to the instance metadata verified, at last we need to attach an IAM role to the instance to give SSM agent necessary permissions to talk to the endpoints. We could have attached the IAM role when initially launching the instance, but because I want to walk you through the checklist of things that the SSM agent verifies before it reports as a managed instance, I'm attaching the IAM role after the instance is launched. So let's proceed to do that. I'm going to switch back to the AWS console and navigate to IAM. I'm going to create an IAM role, select EC2, click on Next. By default, we do have an AWS managed policy for the SSM agent to use in order to connect to the endpoints, which is called as Amazon SSM Managed Instance Core. So I'm just going to look for that policy. Let me select that policy, click on Next. I'm going to name it as EC2 role for SSM, and then click on Create Role. Now that the role is created, let's proceed to attach the role to the instance. So let me select the instance, click on Actions, Security, and Modify IAM role, and select the role that we just created and update the IAM role. The SSM agent runs health checks every 5 minutes in order to report its connectivity to the SSM agent endpoints. So it would take some time for the instance to report as a managed instance in the SSM agent console. If you do want to speed up this process, I would recommend you could either restart the instance or just start the Amazon SSM agent from within the instance if you do have access to it. So let me switch over to the Systems Manager console. Now that we are in the Systems Manager console, I'm going to navigate to Fleet Manager. You can see that the instance is not yet reported as a managed instance in Fleet Manager. So as a quick check, I'm going to go ahead and restart the SSM agent so that it just reports a little bit sooner than expected. So let me switch over to the EC2 machine. Type in services. Select the Amazon SSM agent and just restart the service. Restarting the service will ensure that the SSM agent attempts to reach out to the endpoints, and that way it would report it as a managed instance much sooner. So let me refresh the page. You can see that the instance is now reporting as managed and the node state is running. The SSM ping status is online. With the IAM role attached, the agent now has permissions to communicate to the endpoints. This is how you can configure the SSM agent on an instance in a public subnet to report as a managed instance. Let's now repeat the same process for an instance in the private subnet and verify that it also reports as a managed instance. So let me navigate back to the EC2 console. I'm going to name the instance as Windows Server -private. Select the Windows AMI. Leave the defaults. For the network settings, I'm going to select the VPC that we created, but this time I'm going to select one of the private subnets. You can see that the auto-assign public IP is disabled by default for a private subnet since we only want a private IP. Let me create the security group, call it as the private security group. To leave the RDP inbound security group to default, but only change the source IP to my public IP address. Leave the storage configurations as default and then proceed to launch the instance. Let me click on view all instances. I'm going to give it a couple of minutes for the instance to be in the running state and then for all the status checks to pass. You can see that the instance is running, but the status checks are still initializing. So I'm going to give it a couple of more minutes. Now that the instance status checks has passed, let's try to connect to the instance. Since the Windows machine is in the private subnet, I can only connect to this instance from my instance in the public subnet. So let me just modify my security group rules of my private instance to allow inbound RDP traffic from my public instance. So let me select the public machine and grab its private IP, switch over to my private instance, select the security group, edit the inbound rule, and provide the private IP address of my public instance and click on Save the Rule. I'm now going to grab the private IP address of my instance and then use that to log in from my public instance. Let's attempt to connect to the instance. By default, the username is administrator. And let's decrypt the password from the AWS console. Click on Connect, RDP client, click on Get Password and upload my private key file and then decrypt the password. Let's use this password to connect to the instance. Now that we're logged in to the private instance, I'm quickly going to skim through all the items that we did in the checklist for similar to what we did for the public instance. So let's first verify the sysrep state real quick. I'm going to navigate to the regedit. Click on HKey local machine, software, Microsoft, Windows, current version, setup, and then state. And verify that the image state is image state complete. Once that we've verified that, we'll quickly verify that the SSM agent is running. You can see that the Amazon SSM agent is running. By default, the Windows firewall will have all outbound rules allowed. So let's quickly verify that as well. You can see that the public profile is active and the Windows Defender firewall rules for the public profile allow all outbound connections. Similarly, on the AWS console, let's verify that the security group that we've created for the private instance also has an outbound rule to allow all traffic. We can see that. And next, we'll also verify the NACL rule. So we'll switch to the networking console, the subnet. Select the network ACL and verify that the network ACL is by default. Next, we'll quickly verify that we can resolve the SSM agent endpoints as well as connect to them from within the instance. So to do so, we'll repeat the same commands for nslookup, ssm.region, which is AP Southeast 2 in my case, Amazon AWS.com. You can see that the SSM agent endpoint resolves to a public IP. We can repeat the same test for EC2 messages. AP Southeast 2.amazonaws.com. We can see that the EC2 messages endpoint also resolves to the public IP. We'll now test the connectivity to these endpoints from the instance. So we'll run the test-net connection, the computer name, which is the name of the endpoints. So let me copy the endpoint name and paste it here. And add the port number as 443. We can see that the TCP test has succeeded for the SSM agent endpoint, and we'll repeat the same test for the EC2 messages endpoint. We can see that the TCP test has also succeeded for this endpoint. And lastly, we'll verify that we are able to reach the instance metadata on this instance. So I'm going to browse to http 169.254.169.254. Once that we have verified that the instance metadata is reachable, let's now switch to the AWS console and attach the IAM role for the instance so that the SSM agent has the necessary permissions to connect to the endpoints. So let's switch over to the instance console. Click on Actions, Security, and modify the IAM role, and select the IAM role that we created earlier and update the IAM role. Since the health checks are running every 5 minutes, in order to report the instance immediately as a managed instance, let's go ahead and start the SSM agent on the instance. I'm going to switch over to the services console, click on Amazon SSM agent, then restart the service. Switching back to the Systems Manager, Fleet Manager, let me refresh the console. You can see that the instance in the private subnet is also reporting as a managed instance with the SSM agent ping status is online. Now we have verified all the steps in the checklist and successfully configured the SSM agent for instance in the private subnet. If you have trouble following any of the steps that we recorded in the checklist, or you notice that the instance is still not reporting as a managed instance, I highly recommend that you check the SSM agent logs. They are located in the C drive, Program Data, Amazon SSM logs, and you can read the Amazon SSM agent logs to check for any errors and possibly debug those errors. This covers the steps to configure the SSM agent on instances in private or public subnet as a managed node. I hope this checklist will help guide you in the process. As you would have noticed, the steps are identical in both cases. All that matters is the underlying network configuration for instances in public subnets to communicate to the SSM endpoints via Internet Gateway, and for instances in private subnets to communicate with the endpoints over NAT Gateway. Thanks for watching. For more such content, please don't forget to like, share, and subscribe to Unmask It Now. Until next time.